Techniques for controlling the world around us are at the heart of all our technologies. Feedback control is one way that we are able to make the world around us do what we want, by continuously monitoring a system that we want to control, and then applying different controls to adjust our system to do what we want. A common technology that we encounter in our everyday lives that uses feedback control is the cruise control in our car. If we want to travel at a constant speed of 50 miles per hour, our cruise control can do that for us by monitoring the speed that our car is going at a current time. If it's going along at 50 miles per hour, nothing needs to be done. But if we encounter a headwind and our car starts slowing down, the cruise control can add more gas so that we can continue going at 50 miles per hour, or slow us down if we start going downhill and picking up speed. Sometimes the situation is a little bit more complicated, though. As we continue to push the limits of our technology, we enter scales where the bizarre quantum mechanical properties of the world around us become important. Technologies that operate at these scales allow us to do amazing things, such as measure distances that are thousands of times smaller than the diameter of a proton, or perform calculations that might take longer than the age of the universe if we were to try and do them on the world's fastest supercomputers today. With such great power comes a lot of additional complications, though. One of the bizarre properties of quantum mechanics is that when you measure a system, the very act of measuring it can change it in some way. Our cruise control didn't have to worry about whether measuring the speed of the car would change its speed from 90 miles per hour to 30 miles per hour. But this is exactly the kind of problem we face when we try and control quantum systems. My research involves quantifying the changes that happen when we do look at the speed of our quantum system. By writing down equations that can predict the ways that systems change when we measure them using different techniques, not only are we able to determine what kind of adjustments we need to make to keep our quantum systems doing what we want them to do, but we can also figure out what measurements we should be making in the first place so that we can figure out the most relevant information about the systems we're trying to control while disturbing the systems in the least harmful way. Thank you.